LLM-generated code should not run inside your app process. E2B gives it a sandbox, so code tools can execute without exposing everything. You'll walk away with a setup that runs generated code inside a boundary with blocked secret access. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Many teams let models generate Python and then worry about where that code runs. If generated code executes inside your server or notebook, a single bug or malicious snippet can read secrets, modify files, or hog CPU. The practical problem is protecting secrets and stability while still letting LLMs do dynamic work. Success here means generated code can run, return useful results, and never see your full production environment. At a high level, E2B Sandbox is the safety boundary. Think of it as a tiny remote worker that runs one snippet at a time with strict inputs and time limits. You give it a string of code, a narrow environment, and a timeout. It runs, then returns a tidy execution object with text, logs, or errors, so your app can decide what to do next. We will build a progressive toy runner that shows safe execution, scoped secrets, retry selection, structured error reporting, and a simple preflight guard so agents only run approved code. You will see how the app process never evaluates model output directly, and how the sandbox reports back actionable fields before we scale or harden this further. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To prove the basic path works, we first create a sandbox and run a tiny expression through it. This snippet creates an E2B sandbox and runs the smallest useful Python expression inside it. The app process only creates sandbox, then sends code through sandbox.run code instead of evaluating generated code locally. That separation is the baseline safety move. LLM-written Python executes in the E2B environment, not inside your web worker, API server, or notebook process. The returned execution object gives the interpreted result through execution.text, which is easy to log or return to a tool caller. The visible output proves the remote execution path works before adding files, guardrails, or debugging, and it shows you the minimal round trip you will build everything else on. Now that remote execution works, we need to give code limited inputs without exposing production secrets. This example passes a scoped environment variable into E2B Sandbox for one code execution. Generated code often needs a token-like value, but you do not want it freely reading whatever happens to exist in your production process environment. Here, envs makes the input explicit for sandbox run code, and the sandboxed code reads only app secret from its own execution environment. The result comes back through execution.logs.stdout, which is useful when the code prints rather than returns a final expression. Seeing the printed value in logs shows the sandbox saw the intended scoped value, and that secrets flow is explicit and reviewable. With secrets isolated, we next want to handle multiple generated attempts safely and pick the best result. This code evaluates several candidate code strings in E2B Sandbox and selects the best successful result. LLM apps often retry, repair, or generate multiple possible snippets, so the runner needs a safe way to compare outcomes without one bad candidate crashing the host app. Each candidate goes through sandbox.run code with timeout 2, then OK filters out executions where execution.error is present. The max call ranks the remaining outputs as integers, keeping the ranking logic in your app while execution stays isolated. The visible output shows the selected successful result, which is the core loop behind safer agent retries and ensemble generation. Failures will happen, so we must turn crashes into structured, debuggable signals instead of raw exceptions. This snippet turns a failing E2B Sandbox execution into a small, structured debugging signal. In production, the problem is not just that generated code fails. It is that you need enough detail to triage without dumping unsafe or noisy output everywhere. Bad code raises an indexing error inside sandbox.run code, and the host app reads execution.error.name instead of treating the failure as a local Python exception. The timeout equals to parameter also gives this run an execution budget, which helps contain slow or stuck code paths. The visible output shows the error class, giving monitoring and logs a stable field to group failures by. Finally, we add a tiny preflight so an agent does not run disallowed operations, even if the sandbox would technically execute them. This example wraps E2B Sandbox execution in a tiny guard function for an agent workflow. The host app first checks agent code for operations this tutorial does not want to allow, then sends approved code to sandbox.run code with a timeout. The string check is a deliberately small teaching preflight. Real systems usually pair policy checks with stronger sandbox configuration, review, and observability. The important flow is that run agent code decides whether to block or execute, while E2B remains the place where approved Python actually runs. The visible output shows a complete baseline. Generated code was accepted, isolated, executed, and returned as a result. If you map this toy runner to a real project, the same pieces scale up. The sandbox becomes a managed service or container with image pinning. The envs model turns into secrets provisioning per job. Candidate evaluation becomes a retry and repair policy. And error fields feed your observability system. 3 quick takeaways. It is a remote execution boundary that isolates model-written Python from your process. Use it when you need dynamic generated code, but cannot risk exposing secrets or stability. 1 caveat. The sandbox surface is not a policy. Pairing it with policy checks, image hardening, and monitoring is essential. To extend this example, tune the timeout parameter we used as 2 seconds, and observe how longer tasks behave, while keeping sensible limits and retries. Adjusting timeout is the most direct lever for heavier generated tasks. If practical AI engineering helps you, subscribe and watch the AI engineering videos.